Hello, it is Sulfur 16, the chemist. Today we have a setup, and this setup is of a circuit. In the circuit, there are two bolts fixed in a cork, and the bolts are connected to the battery, to the bulb, to the switch as shown in the video. However much the switch is closed, there will be no flow of current and the bulb will not glow. This is because the bolts are fixed in a cork, and a cork is a bad conductor of electricity, and the bolts are not connected at all. Okay, we have our circuit and we have dilute sulfuric acid. For the circuit, even if the switch is open or it is closed, the bulb will not glow because there is no flow of current as stated previously. Let us see what actually happens when we dip this cork into the dilute sulfuric acid. Wow! The bulb glows, or the bulb produces light. This is because there is flow of current from the bolt connected to the positive terminal to the bolt connected to the negative terminal. Explanation: sulfuric acid, when dissolved in water or when it is diluted, it dissociates in two ions according to the equation on the screen. From the equation, dilute sulfuric acid dissociates in two hydrogen ions and sulfate ions. When the cork is dipped into dilute sulfuric acid, these ions are free to move from the bolt connected to the positive terminal to the bolt connected to the negative terminal. In the process, the ions carry charges and allow the solution to conduct electricity. Thus, the bulb produces light. And this process is known as electrolysis. What is meant by the term electrolysis? Electrolysis is the chemical decomposition produced by passing an electric current through an aqueous solution containing freely moving ions. Or, electrolysis is the process by which a chemical compound in aqueous solution undergoes chemical change on passage of electric current. Electrolysis can also be defined as the passing of electric current through an electrolyte, which produces a chemical reaction at the electrode and the decomposition of the material. The key words in the definitions are chemical decomposition or chemical change of an aqueous solution and electric current flow. Similarly, we have our glucose solution as shown. We have the same circuit. Now, let us see what happens when we dip this cork into glucose solution. Oh, the bulb failed to produce light whether the switch is opened or it is closed. This is because there is no flow of current when the cork is dipped into glucose solution. Explanation: glucose solution does not dissociate whether the glucose solution is saturated or it's not. What is meant by the term saturated solution? Saturated solution is the solution that contains the maximum amount of the solute that is capable of dissolving. What is meant by the term dissociation? Dissociation is the process of breaking down the substance into ions that are already present in that substance. Now, since the glucose solution does not dissociate like dilute sulfuric acid, no ions are formed to carry charges from one bolt to another. And therefore, there will be no flow of charges through the circuit when the cork is dipped into glucose solution, and the bulb will not produce light. Still, we have the same circuit and ethanol solution. We want to see what happens when we dip this cork into the ethanol solution. Still, the bulb does not produce light when the cork is dipped into ethanol solution. Explanation: Ethanol does not dissociate whether it is in its pure form or when it is diluted. Since it does not dissociate, ethanol solution contains no ions and therefore no charges will be carried from one bolt to another, and there is no flow of charges through the circuit, thus the bulb is not producing light when the coke is dipped into ethanol solution. And lastly, we have our circuit and we have potassium chloride solution. Let us observe what happens when we dip this coke into potassium chloride solution. Wow, the bulb produces light, and this implies that there is flow of current through the circuit when the coke is dipped into potassium chloride solution. Explanation: potassium chloride is an ionic salt, and when dissolved in water or when it is in its aqueous form, it conducts electricity. This is due to the fact that when it is in its aqueous form, it dissociates completely into its ions, that is, potassium and chloride ions, according to the equation. These charged particles, that is, the ions, must be able to move freely within the potassium chloride solution. And in that process, they carry charges from one bolt to another. Thus, the bulb produces light when the coke is dipped into potassium chloride solution. Okay, my question to you, the learners. Why do you think the bulb produces less light when the coke is dipped into potassium chloride solution, and it produces more light when the coke is dipped into dilute sulfuric acid? I need your answer. Thanks for viewing this video. I think this video is useful to you. Share this video to your friend such that your friend gains the same thing you've gained today. And don't forget to subscribe to this YouTube channel. This is Sulfur 16, the chemist. We meet.